Hello, my little mathematicians. Today, we're going to explore several word problems involving volume. So let's go ahead and take a look. Okay, the first one says the Jones family is moving and are going to rent a large vehicle to help move things. Okay, it costs $79.50 per day to rent a moving van and $162.75 a day to rent a small truck. Based on the amount of space inside the van or the small truck, which is the better deal? Explain your answer. The hint is find the price per cubic foot. So the price per cubic foot, cubic feet means feet cubed or feet to the third power. That sounds like what? Sounds like the volume. So find the volume of them first and then do the price divided by the volume of each amount. So when we're looking at these, let's first of all find the volume of the moving van, and then we'll find the volume of the small truck. But when we want to plug our numbers in, you'll notice that some of them, when we do length times width times height, because that's how you find volume, they involve fractions. So let's convert all the fractions to decimals using division. Meaning I know that 10 and 1/5 is 10 point something. 10 point what? I hope you guys didn't say 10.5 because 10 and a half is 10.5. So to get this fraction to a decimal, do top divided by, that's what a fraction bar is, the bottom, 1 divided by 5. So you type that into your calculator, 1 divided by 5 is 2. So 10 and a fifth is 10.2. Okay, the next fraction, 7 and 3/4 is 7.75. And then we might deal with a large truck later. 8 and a fourth is 8.25. And 9 and a half, hopefully you have that memorized, is 9.5. Now we can just plug those numbers in. So when I'm focusing on the volume for the moving van, length times width times height. So the moving van's length is 10.2, the width is 6, and the height is 5. Okay, go ahead and multiply all those together, and you get 306 cubic feet. Let's focus on the small truck. Okay, its length for the small truck is 12, the width is 7 3/4 or 7.75, and the height is 7. Plug all that into your calculator, and you get 651 cubic feet, or feet cubed. Okay, we want to find the price per cubic foot. So how much was it to rent the moving van? We said it was $79.50. So take the price, divide how much volume the moving van has, and when you divide those, you get 26 cents, okay, because we rounded it off and we got 26 cents. Okay, the next one, for the small truck, it's $162.75 a day, and it has a volume of 651 cubic feet. So it costs about 25 cents per cubic foot. And you're like, really, a penny doesn't make that much of a difference. So if this is like going to take a lot of trips, then, maybe it's like you'd have to do a little bit more thinking. But at the same time, if it's 26 cents per cubic foot versus 25 cents per cubic foot, it's only a penny difference. So it's not that big a deal if you're only doing one trip. But if it's multiple trips that you're going to need to do, then, hey, every penny counts, right? So then which one's the better deal? You want to spend less money. So you do the 25 cents per cubic foot if it's going to be a lot of trips. Okay, because that's cheaper. Okay. The Jones family is moving and are going to rent a large vehicle to help move things. So we already discussed that. Now our next question is, how much greater is the volume of the large truck versus the volume of the small truck? And then they're also going to ask you if they need to move 1,200 cubic feet of stuff to get all their belongings, and they want to have to do the fewest number of trips to and from their house because it's a pretty long drive, which vehicle should they rent? Okay, because if it's a long commute and maybe they have to rent it for multiple days, depending upon how many trips it takes, let's see if we could figure that out. Okay, first off, they wanted to know just if they were comparing the small truck to the large truck, what's the difference in the volumes? So let's find the volume of the large truck. Well, the large truck's length is 20, the width is 8.25, and the height is 9.5. If you multiply all that, you get 1,567.5 cubic feet. So that's the volume of the large truck. We already found the volume of the small truck up top, right up here. So if we do the volume of the large truck minus the volume of the small truck, we'll find the difference between them. So 1,567.5 minus 651, you get a difference of 916.5 cubic feet. That's how much bigger the large truck versus a small truck is. Okay, so based upon all that information, they want to know, okay, we have 1,200 cubic feet worth of stuff. We want to do the few amount of trips as possible. So which one should we use? Okay, so the smartest thing to do would be to take the cubic feet of their stuff divided by the cubic feet of the vehicle. And then that's going to equal the number of trips they have to make. So if we focus on the moving van first, okay, they have 1,200 cubic feet of stuff, and the moving van had 306 cubic feet. So if you divide those, you get 3.9-ish, which is basically 4 trips, right? 3 trips isn't enough. So 4 trips to get all their stuff moved. Versus if they did the small truck, okay, they still have 1,200 cubic feet worth of stuff, but the small truck has 651 cubic feet. So that would equal 1.8 trips. Okay. That is equal to 2 trips. The large truck, 1,200 divided by 1,567.5, that equals about 0.8-ish if you round it off. So that's about 1 trip. So to answer this question, we're going to say the large truck is the best because it requires the least amount of trips. Because they were focusing on, they want to make the fewest trips because their house is really, really far away. So they basically would have to possibly end up renting the truck for multiple days if they have to do multiple trips. So that's why they focused on least amount of trips. That's what they value more so. But if it's like right down the street and they can make multiple trips, then maybe, if they could do 4 trips in one day, maybe the one that costs the less would be smarter, right? But so that's why there's not just like one guaranteed way to solve these problems. You have to think about it of what's most important to them. Their house is really far away, so they want the few amount of trips as possible, so they only have to rent it for one day. So which one can they get away with? And then the only one that they can do 1 trip with is the large truck. Okay. All right. Let's see. The Jones family also, not only do they need to focus on the vehicle, but they need to put all their things in boxes before they put it in the vehicle. And you have to buy the boxes. So they're like, okay, which company should we go with? Which box contains more room for storage? And how much greater is the volume? Okay, because if you're talking about the room inside of something, that's volume. So the 2 companies that they have the option of are Boxco and MoveCo. So if we find the volume for Boxco, it's length times width times height. Ignore the fact that the length is missing. You still need to multiply it. The MoveCo, length times width times height, and then let's compare them. Okay. Just like before, to make it easier, if there's any fractions, when we go to type them in our calculator, we want to change those fractions to decimals. So 2.5 is 2.5, 3.5 is 3.5. Let's go ahead and type it in. For Boxco, the length is 3, the width is 3, and the height is 3. So 3 times 3 times 3 is 27 cubic feet of space inside the Boxco boxes. The MoveCo boxes have a space amount of 2.5 times 3.5 times 4. Type that all in. They have 35 cubic feet of space inside of their boxes. Okay, what's the difference between them? Because how much greater is the volume? So if you do 35 minus 27, you get 8 cubic feet. So MoveCo has 8 more cubic feet than Boxco boxes. Okay. They, remember, need to move 1,200 cubic feet of stuff. So how many Boxco boxes would they need to purchase? And how many MoveCo boxes would they need to purchase? Then you're like, okay, well, obviously they need to go with the bigger box because then they'll have to purchase less, right? If they have 1,200 cubic feet worth of stuff. But you also have to consider how much it costs per box. So what's better? Okay, so let's focus on, first of all, just finding how many boxes they're going to need of each amount. So if you take their total cubic amount of stuff that they have, 12, divide it by how much cubic feet of space is inside of each box, that'll tell you how many boxes they need to get. So for Boxco, 1,200 divided by 27 cubic feet inside is 44.4. Well, 44 isn't enough boxes, so they'd have to buy 45 boxes from Boxco. If we were to compare that to Moveco, 1,200, the amount of stuff they have, divided by how much space is inside a Moveco box, 35, you get 34.2-ish. Well, 34 is not enough. They would miss some of their stuff, so they have to get 35 boxes from Moveco in order to get all their stuff inside. So let's see which one's the better deal, depending upon how much it costs per box and how many they need to get. So Boxco is $1.49 and Moveco is $1.99 per box. So do the number of boxes they need times the cost of each box from that specific company, and that'll equal the total cost. Okay, so for Boxco, they needed 45 boxes, and it's $1.49 per box, so it equals $67.05. If you compare that to Moveco, they needed 35 boxes from Moveco, and it's $1.99 per box. So that's going to be $69.65 if they go with Moveco. So which one's better? I mean, it's not really that big of a difference, but you know what? Every penny adds up. So it's better and cheaper to go with Boxco. I mean, again, not that much. It's only like $2.60 that they'd save, but still, they'd save some money. Okay, so last thing that we're going to focus on with problems involving volume. We're going to move away from the family that's moving. And let's talk about if we change one specific dimension of a prism, how that affects the overall volume. Okay, so what we're going to do is it says if the bases of the prisms have the same area, but the height of prism A is 3 times larger than the height of prism B, what happens to the volumes? How do they compare? Okay, so we have A versus B. A is 3 times higher, right? So length times width times height, that's how we find the volume. The only thing that changes is notice how we change the height to be 3 times higher than that of B. Okay, the length and width, the area of the two bases are the same. So A is length times width and B is length times width. So the area of the bases are the same, but the height, this is just H and this is H times 3. So let's plug some random numbers in, okay? So if we said the length was 2, the width was 3, and the height was 5, okay, that would mean that the other one still has a length of 2, a width of 3, but the height is going to be 3 times higher than the height of prism B. So 5 times 3, which is 15. So prism A has a height of 15, otherwise everything's the same. Let's see what happens to the overall volume then. Okay, so for prism A, if we do length times width times height versus prism B, you go 2 times 3 times 15, because A, the length is 2, width is 3, height is 15. And then prism B, it's 2 times 3 times just 5, because it's, a quantity of divided by 3 here for the height. So when I find the overall volume for A, multiply those all out, you get 90 cubic units. When you multiply it out for B, you get 30 cubic units. How do those compare to each other? Obviously, A is bigger, but by how much? Prism A is 3 times the volume of prism B. Now, even if you chose different numbers, if you didn't choose 2 and 3 here and 5 here, no matter what, test it with something else. What if this was 3, this was 4, and this was like 8 or 9? And then the only thing is these stay the same as these, but this height is 3 times whatever this was. Will the overall volume still be with A being 3 times bigger than B? Test it. Yeah, it will. Okay, so let's see. We just made one thing bigger. We did the height 3 times bigger. But what if we did the area of the whole base to be 3 times bigger? Does that affect it like being more than 3 times the size? Let's see. Okay. And then if you didn't want to actually plug numbers in, what you could do is right here for A, it's length times width times height. That should say times 3, not times 2, right? Because the height was 3 times bigger. It would be 3 length times width times height. 3 length times width times height for volume A. And then for B, it's length times width times height. And then since the volume of B is length times width times height, I can replace length times width times height with volume of B. So right here, volume of B times, we said this should be a 3. That accidentally got changed to a 2, but we know that it's the height times 3. 3 times the length or the measurement of volume of prism B is equal to the volume of prism A. Okay, so again, let's see if that kind of logic works out the same if we were to change the entire base to be 3 times larger than this base. Okay, so you have prism A and prism B. Remember that the length times width times height, actually that's step 2. Step 1 is volume equals area of the base times height. Big B stands for area of the base. And the base shape of a rectangular prism is a rectangle, so the area of a rectangle is length times width. That's where this comes from. Length times width stands for the area of the base. Okay, so what if I change this thing to be 3 times bigger for A? Okay, so right here, I'm going to change this base to be not just B, but 3 times bigger than that one. So if this is 2 and that's 5, the height's going to stay the same, but we made this be 2 times 3, right? The same base measurement, but 3 times bigger. So the base for A is 6 and the height's going to stay the same of 5. Okay, so for A, area of the base times the height versus B, area of the base times the height. A is 6 times 5. B is 2 times 5. You get 30 cubic units for the volume of A and 10 cubic units for the volume of B. How do those relate to each other? How much bigger is A than B? It's 3 times bigger. Okay, you can see that. Now, if you were to plug in any numbers, as long as you do this number and then the base of this is 3 times bigger than that and you keep the heights the same, you'll see that prism A is always going to be 3 times bigger than the volume of prism B. Because look, you're basically taking the area of the base times 3 times the height for prism A. So 3 times area of the base times height. And for B, it's just area of the base times the height. So if I were to replace area of the base times the height with volume of prism B, because that's what volume of prism B equals, right here you have 3 times volume of prism B is equal to volume of prism A. So A is 3 times that of the volume of B. Okay, now is that true for just if you do it times 3? What if we changed it to the height is 5 times larger? Go ahead and try this yourself first. Hit pause, try it, and then come back and join us. Okay, you hit pause, you tried it, now you unpaused, you're back with us. Okay, for X and Y, we said that obviously we're trying to find the volume. And the area of this base times the height, and the only thing that changes is we're going to make that height for X be 5 times bigger than the height for Y. Okay, so the area of the base for Y times the height. And notice how these match. The height is just X is 5 times bigger than that one. Okay, so let's see what happens. Is it going to be the same where X is 5 times the volume of prism Y? Let's see. Okay, well, A, the area of the base, and then the height is going to be 5 times bigger. Okay, so 5 times area of the base times the height. For B, you have the area of the base times the height. So I can replace area of the base times the height with the volume of prism B. So right here, area of the base times the height, that's right here. So 5 times the volume of prism B is equal to the volume of prism A. Okay? So that pattern held up. What about if for X and Y, this time we don't make the height 5 times bigger, but we make the base 5 times bigger? Okay, so same formula, we're still dealing with volume, and you have the base and height for X and the base and height for Y, but this time we are making the base of X 5 times bigger than the base for Y. Okay, is it still going to be the same thing where prism A, the overall volume is going to be 5 times bigger than the volume of prism B? Let's see. You can either do it kind of like how we did up above, or you can plug specific numbers in. Let's see. Okay, so hit pause, try it yourself. Okay, now you unpaused it, you're back with us. For A, we made the area of the base be B times 5, and then times the height. So that's 5 area of the base times the height. And for the volume of prism B, it's area of the base times the height. So we can substitute area of the base times the height with the volume of prism B. So right here, the volume of prism B times 5 is equal to the volume of prism A. So the volume of prism A is 5 times larger than that of the volume of prism B, because prism B is just area of the base times the height. And if you guys plugged in specific numbers where the heights matched, and then whatever you picked here for the area of the base, this one was just 5 times bigger, you'll notice that when you plugged them in to area of the base times height, the overall volume, A, was always 5 times bigger than B. So just interesting to think about. If you change one dimension, it's going to affect the overall volume to be that many times bigger. Okay. If something like that were to come up on SBAC, my hint to you is just try to plug numbers in and then see what happens and compare them, and then look for the pattern of how many times bigger the one thing is than the other. All right. Congratulations, my little mathematicians. You have mastered quite a few difficult word problems involving volume.